Greetings, fellow mathematicians. We're going to take a look at an example where there's a little bit more work for us to apply the alternating series test. As always, start by identifying b sub n. This one, it might not be as obvious, so let's go ahead and, as always, rewrite this. I'm going to pull the alternating term, -1 to the n minus 1, out front. And that's going to leave me with the fraction n divided by n squared plus 1. And basically whatever's multiplying the alternating term, that's your b sub n term. So let's go ahead and define b sub n as n divided by n squared plus 1. Now for this term, it's very easy to check the limit of that as n goes to infinity. And that's going to be condition 2. So if we take a limit of that term as n approaches infinity, this one you can apply L'Hopital's rule. Notice here your denominator has the bigger power. That's going to get bigger faster. Either way, you'll find this limit does go to 0. So condition 2 is satisfied, but we still need to check condition 1, that this is actually decreasing. And again, it's not just as simple as stating that it's decreasing. There's some work that your professors, myself included, are going to be looking for. Now, when it's not obvious, you might want to check a derivative. Now, you can think of here n as the variable. Some professors might want you to write this as a function of x, the difference between a discrete variable n and a continuous variable. So let's just make sure I have all of you covered. Let's go ahead and turn this into a function of x. So let's just go ahead and replace all n's with x, in case your professor is one of those jerk professors that want you to use x. So let's define this as x divided by x squared plus 1. And we can easily calculate our derivative using the quotient rule. It's probably been a while, so let's go ahead and run through that. All right, so we're going to differentiate the numerator. That comes out to 1. That multiplies the denominator. And then we subtract the numerator times the derivative of the denominator. Maybe you have your orders in the multiplication switch, but this should be equivalent. And then we divide by x squared plus 1 squared. Now you can go ahead and simplify this. Notice this term here, you can multiply that to get 2x squared. We don't really need the parentheses in the multiplication by 1 here. And what we're left with is x squared minus 2x squared. That's negative x squared. So we can write this numerator. Don't forget the 1 in the parentheses. That numerator, we can write it as 1 minus x squared, and that's divided by x squared plus 1 squared. All right, now you can see what happens to the numerator when x equals 1. The numerator is going to become 0. As soon as x gets bigger than 1, your x squared term, what you're subtracting, gets bigger than 1. So the numerator, and hence the whole fraction, because the denominator is squared, will become negative. So let's just observe here, this is going to be negative when the value for x is greater than 1. And what that shows for us, keeping in mind here that x typically can be any real number, our variable n, that's going to count discrete integer values, 1, 2, etc. So the first positive integer bigger than 1 will be 2. So what we can say here from this calculation is that b sub n is decreasing eventually for a certain value of n here, which is 2 and beyond. All right, and again, to make sure that you understand why we're making that conclusion that b sub n is decreasing, we turned b sub n into this function of x, and then we showed that the derivative of that function is negative when x is bigger than 1, which is equivalent here to saying n is greater than or equal to 2. All right, those are both the conditions that we need, and we can reach the conclusion with the alternating series test that our alternating series is convergent. So just to write that down to make it official, we reach the conclusion here that our infinite series, which is alternating, this is convergent. All right, this one was fairly straightforward. And again, don't forget, when it's not obvious, or to make sure that you're earning proper full credit, provide some work like that on your quizzes or exams or homework, and you should be getting full credit for a problem like this. Hope you enjoyed the short video. If you did, support the channel, hit that subscribe button.